Hi guys, so today we're going to go over derivatives of exponential, logarithmic, and inverse trig functions. So before we get started, make sure that you have your calculus sheet of the derivatives I provided in the beginning of Module 3. I also have what we're going to use today just copied onto the slide here, but just so it's easier, make sure you have it out in front of you as well. So we're going to start by finding the derivative of number 1. And if you look, I am multiplying a function of x by another function of x. So that means we're going to apply the product rule because we have two functions of x being multiplied together. So the first function, f, would be 3x squared. And the second function, g, would be the inverse of cosine. So before we apply the product rule, which is f prime g plus g prime f, I have to find the derivative of each one of these as well. So f prime would be, using the power rule, 6x to the first power. And g prime, if you look at the inverse, it gives you negative 1 over square root of 1 minus x squared. So we're going to note that down here. And then from here, I'm just going to replace each function with this respective expression there. So f prime would be 6x times g, which would be the inverse of cosine, and then plus g prime would be negative 1 over the square root of 1 minus x squared times f, which would be 3x squared. So all I'm going to do here is clean it up. There's nothing to do in the first term because, well, I have 6x times the inverse of cosine of x, and there's nothing I can do there. The plus and negative, I'm going to change to minus, and to multiply fractions, we just go straight across, and the fraction form of 3x squared is 3x squared over 1. If I go straight across, that would give me 3x squared over the square root of 1 minus x squared. Remember, I already moved that negative as a minus sign, so that plus negative is just minus. And there are no like terms to add and subtract, so this would be my derivative. Now for number 2, we have one of those issues where I could take the derivative of the exponential base e. I could also take the derivative of its exponent for x. So I'm going to apply u by substitution. So that means I'm going to set u equal to 4x. And then I'm going to write this function as e to the u power. So that means I'm just going to find the derivative of e to the u power. So e to the u power, if you look at your derivatives again, the derivative of e to the x power, or e to the u power, is just e to the x power, or in this case, e to the u power. So that's what the derivative is. Since I'm deriving u, I'm going to put du over dx. Now I do have to find out what that is. So the derivative of u with respect to x, I'm going to go back to u and find the derivative of it. Using the power rule, 4 times 1 is 4, and then x to the 0 power is just times 1, which we don't need to write down. So I've already found the derivative, and all I need to do is just replace the u with whatever it is. So instead of e to the u power, it'll say e to the 4x power. And then times du over dx, which is just 4. And to just clean this up, I'm going to put the coefficient right in the front. And that's pretty much it. Okay, we have 2 problems left. So same thing here as in number 2. You can take the natural log of x. You can take the derivative of natural log. You can take the derivative of 3 plus x. So I have 2 things happening here. So again, I'm going to take a sidebar and rewrite this as u equals 3 plus x, so that the function itself is now natural log of u. Well, this should be u, but f prime. So I have to find the natural log of u's derivative. So again, I'm going to go to that first page. The derivative of natural log is 1 over x, or in this case, it'll be 1 over u. And again, since I'm deriving with respect to u, times du over dx. So I have the derivative, I just need to replace everything back in. So I have u, which is 3 plus x. I need to find out what the derivative of u is with respect to x, and that would be, you're just taking the derivative of each term. So the derivative of any constant is just 0, that's gone. And then the derivative of x is 1. Because remember, if we put the exponents in the power here and the coefficient, we can use the power rule. So plugging this all back in, this will give me 1 over u, which is 3 plus x. And it's being multiplied to du over dx, which is just 1. So anything times 1, even if we multiply straight across, it'll still be the same. So it'll just be 1 over 3 plus x. All right, guys, we are almost done. Hopefully you remember your natural logs and e and condensing and expanding, because there's a little algebra approach you can take here first. So they're asking for the derivative of e7 natural log of x. Now, when you condense natural log or e, coefficients can become exponents. I don't know if you remember that from algebra, but coefficients can become exponents. So I'm going to move that 7 up. I haven't done anything calculus-wise, no derivative. I'm just using my algebra to kind of clean up what's in the parentheses. And then remember, e and natural log eliminate one another. So that means I am just left with x to the 7th power. Technically, they become 1, but I'm just going to say they eliminate each other because 1 times x to the 7th power is just x to the 7th power. So after I clean up the exponential, logarithmic, natural log thing I've got going on there, algebraically, by the time I get to the derivative, all I'm doing is just taking the derivative of x to the 7th power, which I can use the power rule, and that will give me 7x to the 6th power. All right, guys, I hope this helps.